Buenas tardes. Hello. Hello, everybody. Good afternoon. Boa tarde. I am Andrea Coronato. I'm researcher of CADIC CONICET at Ushuaia in Argentina. I am also one of the IAG vice presidents and the Latin American co-opter of IAG. IAG is the International Association of Geomorphologists, as you may know. Together with my colleague from Universidad Federal de Bahia in Brazil, Grace Alves, we are in charge to coordinate this fourth IAG webinar to celebrate the 2024 International Week of Geomorphology for this part of the world, for our Central and South American territories. This is an official activity of IAG, so the presentations and some lectures must be in English. But anyway, we also use Spanish and Portuguese, our local languages, for some lectures, for questions, for comments. So please feel free to participate in any of the three languages. All of them are accepted. Buenas tardes a todos, ahora en español por las dudas. Soy Andrea Coronato, soy investigadora de CONICET en el CADIC, en Ushuaia, y una de los vicepresidentes de la Asociación Internacional de Geomorfólogos, más conocida como IAG o IAG, y además soy representante para Latinoamérica de esta asociación. Y hoy, junto con Grace Alves, mi compañera de la Universidad Federal de Salvador de Bahía y secretaria de la Unión de Geomorfología de Brasil, estamos encargadas de organizar y de llevar adelante este cuarto webinar para celebrar la Semana Internacional de la Geomorfología del año 2024. Esta es la cuarta oportunidad en que nos reunimos en esta primera semana de marzo para realizar esta actividad. Les decía que como es una actividad oficial de IAG, el idioma oficial es el inglés. Por eso abrimos la reunión hablando en inglés. Pero de todos modos podemos hablar en español, en portugués, y les pedimos a todos que por favor se sientan libres de hacer preguntas, comentarios en cualquiera de los tres idiomas, porque todos son aceptados. Grace?
Boa tarde. Boa tarde a todas e todos. Eu sou a Grace Alves, sou professora na Universidade Federal da Bahia, sou secretária da União de Geomorfologia Brasileira e estou aqui junto com a Andrea Coronato, pesquisadora do CADIC CONICET em Ushuaia, Argentina, também vice-presidente e representante da América Latina no IAG. Nós estamos encarregadas de dar boas-vindas a todos e todas que estão aqui assistindo o quarto webinar para celebrar a Semana Internacional de Geomorfologia. Por esta ser uma atividade do IAG, né, da Associação Internacional de Geomorfologia, nós utilizaremos o inglês em algumas apresentações. Também vamos comentar e perguntar e discutir em espanhol e português, que são as nossas línguas locais. Então, por favor, se sintam à vontade de fazer perguntas em português, em espanhol, em inglês, a que for mais conveniente, que nós iremos repassar para os jovens profissionais de geomorfologia que estão apresentando hoje, para que a gente tenha aí uma rica tarde. Andrea?
6 young geomorphologists from Costa Rica, Brazil, Chile, and Argentina, some of them living abroad or working abroad, are the protagonists of this webinar, in which they will share their results coming from postdoctoral studies or coming from their participation in research projects. We want to deeply thank to all of them. 6 geomorfólogos de Costa Rica, de Brasil, de Chile y de Argentina son los protagonistas del webinar de 2024 y ellos van a compartir con nosotros los resultados de sus estudios doctorales, postdoctorales o de resultados de los proyectos de investigación en los que están o estuvieron involucrados. Queremos agradecer profundamente. We want to deeply thanks to Raquel Granados Aguilar from Costa Rica, but living in the United States, Joao Paulo Soares de Cortés and Renata Jordan Enríquez de Brasil, a Ignacio Ibarra Cofré de Chile, aunque viviendo en el Reino Unido y trabajando en Reino Unido, y también a Mariana Correas González y a Damián Groch, ambos de Argentina. A todos les agradecemos ser parte de esta actividad. We are very thankful to all of them to accept to be part of this activity.
Teremos, então, 6 profissionais em geomorfologia dos países Costa Rica, Brasil, Chile e Argentina, alguns destes vivendo e trabalhando fora da América Latina, que vão compartilhar com a gente os resultados de suas pesquisas. Gostaríamos de agradecer, então, a Raquel Granados Aguilar, da Costa Rica, João Paulo Soares de Cortés e Renata Jordan Henriques, do Brasil, Ignacio Barra Cofré, do Chile, Mariana Correas Gonzalez e Damián Groch, da Argentina, por terem aceitado esse convite para fazer a apresentação de seus trabalhos hoje aqui. Muito obrigada.
We hope the dissemination of the results of their work will motivate to other young researchers, students, and professionals to discover the remaining questions about landforms and processes of the Earth's surface, and their interaction with the atmosphere, lithosphere, and biosphere, as well as with the society and its infrastructure. Also, we hope to reach the IAG intention to promote this type of meetings, useful to know each other's, and to strengthen geomorphology in our continent. Esperamos que la difusión de los trabajos de nuestros disertantes sea una fuerte motivación para otros jóvenes estudiantes, investigadores, jóvenes profesionales, para descubrir los interrogantes que aún se nos presentan cuando estudiamos o cuando nos plantamos frente a geoformas y procesos que modelan o que han modelado la superficie de nuestro planeta. Cuando nos interrogamos acerca de sus interacciones con la atmósfera, con la litosfera, con la biosfera y con la sociedad que sobre ellos habita y sobre la que implanta su infraestructura. Asimismo, también es intención de la IAG que estos encuentros sirvan para reunirnos anualmente, para conocernos, para fortalecer el desarrollo de nuestra disciplina en nuestro continente americano.
Esperamos que a divulgação dos resultados dessas pesquisas possam servir como motivação para jovens pesquisadoras e pesquisadores, estudantes e profissionais para buscar as questões associadas às geoformas e aos processos que têm modelado a superfície de nosso planeta, assim como suas interações com a atmosfera, litosfera, biosfera, com a sociedade e o espaço produzido. Assim, esperamos que essa proposta do IAG possa acontecer anualmente para que possamos conhecer e fortalecer o desenvolvimento da geomorfologia em nosso continente.
Okay, no more words. It's time to start with our first presentation, ¿no? Ya es momento de presentar a nuestra primera disertante.
Sem mais palavras, a gente passa então para as apresentações. Por favor, André.
Okay, so we go forward, and now I invite to join to Damián Groch. Hola, Damián.
Hi, Andrea. Hi, Grace. How are you?
Hola, thanks to be here. Damián is professor in geography and licenciado, so it's the final degree in University of Comahue at Neuquén City in Argentina. He also have a specialization certificate for the assessment and management of geological and climatic related risk given by the University of Geneva in Switzerland. By these days, Damián is teaching assistant in the degree of environmental planning at the University of Comahue also. So welcome to our webinar. Thank you for your presentation. It is about human-induced earthflows in Northern Patagonia, Argentina, o flujos de tierra inducidos por la actividad humana en el norte de Patagonia, en Argentina. We are very excited to hear you. So go ahead.
Okay, I will share the screen. Is it okay?
Yes, it's okay. You can put in presentation. Yes, that's right. Thank you.
Perfect. Thank you. So I'm a teacher in geography. I'm working on my PhD currently in geography as well in the National University of the South, that is in Argentina. In this PhD, I am working with different kind of landslides in the northern part of Patagonia. So I thought that it is a good idea to present something that I'm working with. I did a research last year with human-induced airflow, so that I'm presenting today. The presentation is called Human-induced earthflows in Northern Patagonia, Argentina. And well, I think there is no. So the introduction of this research is about landslide and how is one of the major natural hazards around the world, causing millions of losses in terms of population, ecosystems, and economies. We have different causes as natural causes and human causes, like urbanization, deforestation, irrigation, among others. These causes are producing disasters in many population centers around the world and are scarcely studied, honestly. So with the changes that are being induced due to climate change and the change of land cover because of the increase of population, of urbanization in mountain slope, the losses are increasing. So the intensity and the frequency on this type of landslide, the climate change and land cover changes are increasing, as I said, sorry. The number of studies of landslide related to anthropogenic forcing is really low. I mean, if you look for the research that is written nowadays, the amount of research due to human causes are really slow. So we thought that it is a good idea to make a research about this subject and contribute with science in this. Right now, the research is mostly circumscribed to China and Peru about irrigation-induced landslides, mainly in these countries because of the agricultural activities and not other causes. So we thought that it's a good idea to study this kind of landslides in Patagonia, just because the land cover and the land use is quite different to other countries. We are living in a sector that pastoralism is the main activity, so the way the land is used is quite different. In Argentina, the anthropogenic activities have been only studied in relation with landslide in Vista Alegre. It's the only research it's the only research that have been carried out linked to water. So Moreira, San Coronato, and Churio are the only papers available. The literature does not present other cases of landslides linked to water management, in spite of the recent cases that have occurred, like the ones that you can see in the figure at the bottom with the yellow stars. We have cases in Villa Langostura, Bariloche, Marimenuco, and Las Grutas, with some casualties, but casualties reported that no formal studies have been carried out. So our study tried to document this kind of landslides in Patagonia, and it is just the second one linked to water here. The objective of this study is to determine the direct and anthropogenic influence on the generation of airflow due to long-term intensive irrigation. The study area exactly is Chenquemalal. Chenquemalal is an area located, as you can see in this figure, with a blue circle that is there, and in the western slopes of Cordillera del Viento. Some examples of airflows can be seen on these 4 photographs that are with some white polygon in the surroundings, in the limits of the airflows. As you can see in the main figure in the map, there are 24 airflows identified with different sizes. The size of the dot means the smaller the dot, the smaller the landslide, by the opposite. So we will talk about today with the landslide that is true, the red circle, that is the biggest airflow, happened in Patagonia, in the North Patagonia. And we are interested in this case because of a collapse recorded on September 22nd, 2020. This collapse produced significant losses in the area. Luckily, no human losses, but we are kind of expecting these casualties in the future due to the amount of airflows that can be localized in this area, and which half of it have collapsed in the last 2 decades. So we wonder what is going on in this area and why do they exist and why they are collapsing. So the study area is Chenquemalal, as I mentioned before. You can see the green rectangle in the upper part of the map, and it's near Andacollo and Huinganco towns that are 2 towns with a combined population of 4,000 inhabitants. And the specific area can be seen in the picture, in the both pictures, that are in the same spot, in a pre-collapse situation and a post-collapse situation, respectively in the upper part and the bottom. The landslide has a white polygon. So you can see there are some other stuff like the route in yellow, the irrigation channel that is linked with the airflow, and some gullies and other stuff. So what is important here is that there are slopes, gullies, rocky slopes with erosion. We have springs there. So we were wondering why these airflows are happening in this specific sector of North Patagonia. The activity here in terms of seismic is moderate. We have volcanism, we have tectonism linked to the movement of the tectonic plates. We have the subduction of the Nazca plate under the South American plate that it creates the Cordillera del Viento, that is the main mountain range here, that is 50 kilometers away of the Andean mountain range. So the methodology that we implemented in this study involved the interpretation of maps, geological, geomorphological, and landslide susceptibility maps with different scales. We use aerial photographs, historical ones from the 1963. We also use in analysis optical satellite images from Google Earth and Airbus, mainly because they are free. So we use them, also Landslide and Sentinel for more recent ones, especially Sentinel because we analyze the humidity and the vigorosity of the vegetation in the area. We also examine the precipitation. We considered extreme events with precipitation greater than 10, 20, and 50 millimeters. And also we used SPI, that is the standardized precipitation index, to know how dry or wet is or was the weather during a 40 years period. That could give us an impression of how was the climate and that period. We also conducted fieldwork. So we did some interviews, we measured some typical morphometric parameters like area, weight, width, length, slope, and volume, the airflow. All information at least with a spatial component was systemized in a GIS, that it was QGIS. We studied the anthropic influence, measuring the water flows or nearby natural springs and irrigation canals, as well as we did some infiltration tests. You can see in the pictures on the right, well, the analyze of some morphometric characteristic, mainly scarps and lobes and other features of the landslide. Also, we took samples, soil samples, some edaphic profiles, and we conducted also infiltration tests. Here you can see the channel that we introduced natural tracers to know where the water that can be seen in the airflow in lower altitudinal sectors of the slope where the water came from. So we did many things there to try to understand and desegregate the natural and the anthropogenic influence. As a result of our research, we did an interpretation of the evolution of the slope. Initially in the 1930s, transhumant livestock activity was developed, at least from that date and on. And 30 years afterwards, a irrigation channel was built. So this area that is typically used for pastoralism, it's good to mention that this area, the people can do transhumant activity, so the animals move seasonally from the lower part to the upper parts of the mountain range because of the availability of grasslands. So during the winter, the animals stay there, and during the summer, the animals move to higher sectors of the mountain. And with the construction of the irrigation canal, the animals could stay a little bit longer in the field. The grassland could recover in a much quick way due to the presence of water. So that's quite good for field owners. And we could prove these changes in the landscape thanks to the aerial photograph and the satellite images. You can see the aerial photograph in the upper part and the Landsat image at the bottom. So we know that it was like that, what people mentioned to us. So we were trying to check everything, because one of the main sources in this kind of areas are interviews, but sometimes you don't have other kind of information to verify this. So we tried a little bit with remote sensing. In 2010, with high resolution images, with the first one, as you can see in the figure on the left, the picture in 2010 shows us some slight deformation and surface irregularities linked to the irrigation. You can see, with the help of my mouse, the channel, the higher parts of the slope, and some dots that means a point of irrigation. So through this point, the owners allow the water to flow down the slope. So you can see the irrigation, the figure is in Spanish because of a research project that we conduct and we published last year. So I used that same figure. I just cut it in two for explaining purposes. You can see how is the flow. You have a secondary channel and the main channel that is Arroyo Chenquimalal, a small river. And we can see some slight deformation, some cracks over there. And as the time passed by, in 2019, we observed some ground variations in the lower sectors, some cracks, some lobes. And you can see here, for interpretation purposes, the airflow, the main body. And you can see how the landscape is changing and how the cracks and the lobes are being created along a long time. So the active airflow can be seen here. It's an active one, but not collapsed yet, in opposition to the one in white that yes collapsed in 2020. So for this period, we wonder, well, what happened with the precipitation? Is it the main cause in the development of this landslide? Well, we found out that the annual precipitation in this area is around 850 millimeters per year, and is mostly concentrated during the winter, during the autumn and the winter time seasons. And during the last 12 years, the precipitation decreased significantly. The amount of events during the same period decreased as well. You can see the annual precipitation in figure A. In B, the quantity of years a year with precipitation. In violet is 10 millimeters extreme event, 20 millimeters in yellow, and in red, the 50 millimeters event. So in the last 12 years, the amount of event decreased notoriously. And for the same period, we calculate the standardized precipitation index for a 12-month period. And you can see that this was mainly moderate to very dry period. So what is going on? Because the increase in the precipitation could be justified by the water deficit in this period. And we associate, as you can see, in this year, in 2019, the higher development of the landslide was during those years. And in those years, we have less precipitation, less extreme events. So what is going on? So we believe that the increase of the irrigation conducted to the development of earthflows. On September 22, in 2020, an airflow collapse occurred in Chenquemalal. You can see the changes in the landscape, all smoky, full of water, and we wondered what happened. We measured the water, the water flow, and we calculate around 38,000 cubic meters of water circulate on that channel. So what happened? A cow got close to the channel to drink water and died in the channel. That dam that was producing the channel produced the partial loss of water. So that water went directly over the airflow that was already there before. So during 28 hours, the water increased the pressure of the slope until the slope collapsed. So you can see the changes in figure D. You can see the change in the topography, the erosion part in red and the accumulation part in blue that we did with GPS measurement. We took around 33,000 points with that they were geolocalized, latitude, longitude, and altitude. So we have the topographic variation. We didn't have back then a drone to do it properly, so we try our best with the information available and the instrument available as well. So we calculate some parameters. We know that it has 364 meters long with around 70 meters wide, affected an area of 22 hectares, 22,000 meters, and the volume was around 19,000 cubic meters, mainly from the collapse initiation sector, as you can see in picture A, the transport and accumulation zones. This landslide, in spite of being an airflow, it was characterized as well from some rotational landslides in the ground of the landslide and some earth slides, as you can see here in picture B. The sediments accumulation downstream, some part of the landslide that was stopped by the vegetation, You can see as well some water from the headscarps, and as I mentioned, rotational landslide in the headwaters. So the displacement of the material was chaotic, as you can see in this profile. This profile is located here, as you can see in this sector. So thanks to the huge amount of points that we took on the area, we reconstruct the previous surface using not only this information, but also the photographs. So the previous surface was a bit smoothie, and then with the collapse, it become really rough and steep. So you can see the change in the elevation, and also the topographic variation there that reach minus 8 meters in the ground and 5.5 meters in the accumulation part here. And some direct measurements were made in the headwater spring of the collapse. As you can see there is some water and some water over there. These springs make us wonder why this water exists there. So we measured the water flow there, and we found out that 3.6 liters per second were flowing out from the earth. So we were wondering where this water came from, because there was a spring nearby, and we found out that the water that can be seen there is more than 100 times bigger than the water flow that can be measured in the springs, that it was 100 meters away, and the water was channelized to other sectors. So the only possible source is from the irrigation channel upstream. We conducted also some geotechnical and geological analysis. We found out the 6 units in the earth. I mean, the profile has 6 units, mainly volcanic, with a mainly volcanic composition, with the exception of the organic stratum on top. We, with the information, found that there is a rapid water infiltration in the 4 units on top, and a less infiltration in the unit below. So we believe, based on all this information, with the Attenberg limits, the classification, the natural water content, and the bulk density, among other factors, that the water infiltrated until it would not infiltrate anymore because of clay particles in the lower sectors. So the weight of the slope, it was so high, and also the deformations on tops, that with the water inputs due to the cow dying in the irrigation channel, caused the sudden collapse of the wall slope and affected the wall area with around $168,000 losses. So the destruction were linked to mainly roads, internal and provincial roads, some fences, animals, the loss of grasslands, among other minor losses. So for us, it was no doubt that it was due to the irrigation of water on the slopes in the long term. But we wanted to discuss as well 3 other possible triggers, as precipitation, and we checked the information that we have available, and we found out that there is a lag time too long lag time between the last precipitation. It was between 4 and 15 days before, and it was only 32 millimeters compared with 38,000 cubic meters. So precipitation was not the cause of the trigger mechanism. Also, seismicity, we know that it's around 6,000 earthquakes happened in the surroundings in a 200 kilometers perimeter, and only 2 minor events happened the previous days, were not considered important enough. And also some springs were considered as well, not only the one nearby. We couldn't find anything relevant that could trigger this airflow. Sorry. As a conclusion, we consider that there is a linkage of continuous water inputs with the generation, development, and collapse of an airflow in the Argentinian North Patagonia. There are considerable disturbances as a consequence of continuous water inputs over decades for the development of transhumant livestock activity. What it was interesting for us was that in the irrigated sector, we found out that airflows evolve independently of climatic conditions, as I mentioned before, with a 12-year period between 2008 and 2020. The collapse produced the mobilization of around 19,000 cubic meters of earth, but we know that an active airflow is still there. I heard, thanks to some people living in the area, that the active airflow that is next to the one that collapsed is moving. So we are expecting another airflow in the near future. Some water inputs induce surface and subsurface disturbances during moderately dry to very dry periods. So if the current condition continue in the near future, as we know that it could happen due some climatic effects, we are expecting other airflow collapses. And well, of course, mitigation measures are highly recommended from us. We are working with some decision makers in the area and also with schools to produce a bit of conscious about these landslides, but there is still much work to do. This research was published in Andean Geology last year, so everyone that wants to know a little bit more about this research could contact me or read the paper. Feel free to contact me at any time. So thank you very much.
Thank you, Damián. It's very, very interesting work. Congratulations.
Thank you.
Very nice, and it's a very good presentation also. Okay, we have 2 questions. Can you answer them very shortly because we are just on time?
Sure. Can you read it for me or
Thank you. I will read them. Yes. Cesar Abad Perez from Peru say congratulations to you for your presentation. Here in Peru, there are many great earth flows caused by bad irrigation practices in pre-Hispanic terraced mountain slopes. Have you considered using radar images?
Yes, radar images will be great to implement it here. I didn't do it yet, but it's something that I will consider it in the future because the available information is really interesting, even though that we here have some economic limitation to implement not radar images, but LiDAR, that it could be even better. So sometimes the available information define what you can and you cannot do in this area. But for sure, what you mentioned is really interesting.
Thank you. Mariana Correas González from Mendoza, Argentina, thanks you for the presentation and says, regarding the infiltration test you did, Were they effective to identify infiltration and springs in the earth flows?
No, they don't, because we introduced some natural tracer, so in the channel, and we wait like 6 hours in the head, in the crown of the landslide, waiting to see if the test was good enough, and it wasn't. So we did the relationship only with the water flows, not with the tracers, because we believe that the amount of time that we took into consideration to see the relation between the natural tracer that was on the channel and the water of the spring in the crown of the landslide, the 6 hours maybe it was good enough. Maybe the amount of time the natural tracer was on the channel in the part of the landslide wasn't enough. It could be that the water velocity, the groundwater velocity, could be much less rapid than we previously thought. So I think that it could be a good way to measure if the infiltration is good or not, and how much time it takes. But it wasn't in our case due to the things that I just mentioned. But I highly recommend it anyway, because it could be maybe the groundwater much quick than, in other places than the one than in the places that we conducted the research.
Okay, and the last from my side, is this practice of channelization in slopes is a very common practice proposed by the local administrations in that semi-arid zone?
Yes, we have hundreds of channels in the area, with dozens and dozens of kilometers of channelizing channels in the area. So it is a common practice. The main problem, the main issue here is that the channels are not impermeabilized. So when in some part of the year, like in summer, the water do not flow because the channel sometimes is dry. So during those months that the water is stay in place, do not flow, that water work on the soil particles at the bottom of the channel. So it could infiltrate, could change the dynamic in the ground. And afterwards, when the rainy season starts and the channels have water on it, it changed the dynamic. So that water could, as the ground changed during the summer and during the spring and the summer, during the rainy season, it could change the infiltration of water during the rest of the year. So yes, it's a common practice, and they are not regulated. So one of the recommendations to decision maker are to create some impermeabilization on it, but there are some population resistant to that because it controls the amount of water that they can put on the slope. So there is a resistance, and they are trying to change some policies in the area, but they are not yet implemented.
Okay, thank you very much, Damián. Congratulations again.